Okay, organic compounds. Early on, chemists divided compounds into two broad categories. They called them organic and inorganic. Anything that was derived from living things was called organic, and things not from living things were called inorganic. They're not organic. So it's just from living organisms or not. The organic compounds were much easier to decompose. A lot of them will burn fairly easily, but they're actually pretty hard to synthesize. The inorganic compounds are much easier to synthesize, to make in the lab, but they're harder to decompose. So that was kind of an interesting distinguishing factor. Today, of course, we've learned how to make these things in the lab, and that's a whole branch of chemistry, synthetic organic chemistry. Very useful thing. So what do we mean by organic? When we say organic compound, we mean it's mainly composed of carbon and hydrogen. So carbon is the main component of this substance. It can have other elements in there. Oxygen, nitrogen, phosphorus, and sulfur are fairly common. It can have other elements as well, but it's mostly carbon and hydrogen. So you go to the grocery store and the word organic is used differently than chemists use organic. Go to the grocery store and you're like, oh, this is organic. This is, it doesn't have pesticides and stuff on it. This is going to be better for me to eat. Organic chemicals, does that mean they're safe? Natural? No. Many organic chemicals are very toxic and dangerous. Even substances that come from living organisms that are completely natural can be extremely toxic. So just because it's natural does not mean it's safe. So here we have a structural formula and a space-filling model for the simplest organic molecule, methane, CH4. It's considered organic because it's just carbons and hydrogens. We talked about types of bonds, ionic and covalent. Carbon bonds in organic compounds are almost exclusively covalent, is sharing electrons. Carbon bonds and makes 4 bonds, almost always. So it'll make 4 covalent bonds. It can make single, double, and triple bonds. It can bond with other carbon atoms or with different elements. And what makes the chemistry of carbon very unique and very complex is that it can make long chains of carbon atoms and make very complicated branched and ring structures. And so the variety is tremendous. So here we have some examples of some organic compounds. So if you look, these are all structural formulas. So if we look at the carbon here, each of these carbons is making 4 bonds. And that is characteristic of carbon. Here we have a branched compound. Here this is a ring. So the carbons is like they're holding hands and playing Ring Around the Rosie. But if you look at them, they still have 4 bonds, 4 single bonds. Here we have one with a double bond between the carbons. So that's 2 bonds for the double and 1 each for the single. Each of these carbons still has 4 bonds. Here's one with a triple bond. Triple bond and a single bond, each carbon still has 4 bonds. Here we have carbon doing a double bond with the oxygen and a single bond with a carbon, single bond with an oxygen. Again, 4 bonds on the carbons. We can take those organic compounds and divide them into hydrocarbons and functionalized hydrocarbons. So hydrocarbons, as the name suggests, contain hydrogen and carbon. And functionalized hydrocarbons have other stuff in there. Hydrocarbons are very useful as fuels. Oil, gasoline, liquid propane, natural gas, those are all hydrocarbons. And when they burn very cleanly and form carbon dioxide and water. Of course, the oil that you're burning may not be pure hydrocarbon. It may have traces of other things, and so that's what gives rise to pollution. Naming hydrocarbons. If you have a hydrocarbon that only has single bonds, that falls into a group called alkanes. And this suffix is important. The ane suffix, ane, says it's got single bonds. If you've got hydrogens and carbons and you've got at least one double bond, that's an alkene, and so we use the ene, the ene suffix. If there's a triple bond, it's an alkyne, and we use the yne suffix. So hydrocarbons have names that follow this pattern. A base name that is determined by the number of carbon atoms, and then a suffix, either ane, ene, or ine, that tells us about the bonds in the compound. What we're doing here with organic compounds is we're giving you just a little tiny taste of how to name them. It actually gets rather complicated. I think it's fun. It's kind of like a game. But we're just going to scratch the surface here. So the base names are listed here. So skip the first four. Pent is 5, hex is 6, etc. So these guys are like those numeric prefixes we used, right? Hexa was 6, hepta was 7. So if you have 6 carbons and all single bonds, it's going to be hexane. What's different is these first 4, and that has to do with history, right? So things were given names before they realized that this was going to get complicated and we should have a pattern, but those have been used so long that we can't get everybody to agree to change. So those first ones you got to kind of memorize, remember. This is how I remember them. Mom eats pickled bananas. It's a silly sentence. The sillier, the better. That one's pretty silly. So M for meth, E for eth, P for prop, and B for bute. So methane, ethane, propane, butane. 1, 2, 3, 4 carbons. After that, it's the numeric prefixes, and it's easy. There we go. Okay, thanks for catching up with me, little iPad. So here's a table just giving some common hydrocarbons. We've got their names, their molecular formulas, structural formulas, space-filling models, and some common uses. And this is more just for interest. I want to point out here propane. So here we have 3 carbons. Mom eats pickled. So P for propane, 3 carbons. All single bonds, so it's got the suffix ane, propane. This is ethene. Eth comes from 2, mom eats, 2 carbons, and there's a double bond. That's why it has the suffix ene instead of ane. Ethyne also has 2 carbons, but now it's got a triple bond. Okay? So those are the hydrocarbons, then we have functionalized hydrocarbons. So a functional group gives a different function to the molecule. And these are grouped by their characteristics. If they have the same functional group, they're going to have similar qualities, similar properties. We can call double and triple bonds functional groups as well, but those don't make it a functionalized hydrocarbon. So if we have a group of compounds with the same functional group, we say that's a family of compounds. So here we have 2 alcohols. So methanol and isopropanol are both members of the alcohol family. What makes them alcohols is that they have this OH functional group. The rest of the molecule is carbons and hydrogens with single bonds, but they've got that OH group. That causes them to react in similar ways, because that's where the reaction occurs. So that's the alcohol functional group. So this is a table all the functional groups. I'd like you to know a couple of them. Okay, so I want you to know the alcohol functional group. So if you see something like this where there's an OH in it, that's an alcohol. Okay, and then carboxylic acids, those are pretty common as well. And here you've got a carbon double bonded to an oxygen and an OH group. So they're similar to the alcohols, but they also have this double bonded carbon. That's good enough. We'll do 2 of them. I want you to be able to recognize alcohols and carboxylic acids. Okay. The rest of them aren't that important at this point in your chemistry education. So draw the structural formula for nonane. That's something you should be able to do. Nonane. What does the non part mean? N-O-N. 9 means 9 carbons. What does the ane part mean? Single bonds. So there's actually more than one structural formula for nonane, but I would take any of them. So we need 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. The structural formula is where you draw all the element symbols and with lines in between. What's the other element present in nonane? Hydrogen. How do we know how many hydrogens there are? How many bonds does each carbon need? Needs 4 bonds. So we'll make sure that each carbon has 4 bonds. They're all single bonds. And the only other element is hydrogens. There must be a hydrogen at the end of each of these. Students who don't like math often enjoy or don't hate organic chemistry, because most of the math in OChem involves counting, and usually not more than 10. So if you can count to 10, you can do the math in OChem. So that's nonane. It's got 9, I almost said 6. It's got 9 carbons, all single bonds. I'm going to change this one because I am. So make this a different thing. So to which family does this compound belong? Carboxylic acid. So it's got this OH, but it also has C double bonded to O. So this is one of the 2 groups I want you to know. This is a carboxylic acid. Carboxylic acids are very common organic acids.